Hello, my name is Dennis, call sign AD6DM, and today in this video I'll be showing you how to make a lithium iron phosphate 12-volt battery for ham radio. Now, why would someone want to have something like this? Why would they want to build one? Well, you see, a lot of ham radio operators either buy these types of batteries or they get sealed lead acid batteries like car batteries, which actually are older technology. Lithium iron phosphate, also known as LiFePo 4, are batteries, a battery technology that actually is fairly new, and it lasts a lot longer for the same size, and it's a lot lighter, and it's a very safe lithium chemistry. And what we'll be doing here is we'll actually be sourcing parts and building one from the individual cells. So let me show you what we have here and what you'll need to build your own lithium iron phosphate battery. Here are some of the components that we have, and first off, what you are going to need are our cells. They're called prismatic cells and are rectangular in shape, and the technology has actually advanced quite a lot since I first built one of these myself several years ago. This is a very small comparative lithium iron phosphate cell, and it's actually, I would say, about half the size of the cells that I built for the same capacity of 100 amp hours. And I said that right. It's a 100 amp hour cell. Now, each of these cells are 3.2 volts. And you can see I have 4 of them here. And altogether, if you put 4 of them in series, you will have a 12.8 volt, 100 amp hour battery. Now, the concepts that I'm showing here are actually the same across lithium iron phosphate cell types. And so what we're going to do is we're going to put this all together, and we'll use various battery components, which are essentially standard across lithium iron phosphate batteries. Now, I have another type of battery here. This is a smaller cell. This is what you call a 32650 sized cell, and these numbers actually have some very different characteristics. They tell you, in kind of encoding into the model name, what those cells dimensions are. And I can't remember exactly what the number is here. I'll show it in editing, but essentially the number of this cell type actually hints to the dimensions. And I measured this cell. It's actually around, I think it's 8 inches here, 8 inches high, about 5 inches wide, and about, I think it was 1.5 inches in depth. So that's what you have there. If you look at like a 4-pack of the blue cells that I showed, they're actually the same concept. You have 4 here, you have 4 cells here, and you will be connecting them in a very similar way. So you could make a much smaller pack for like portable operation, or you can make this larger pack for extended things like field day operation and so forth. The next thing I want to show you is the BMS. So a lithium iron phosphate cell by itself is 3.2 volts, but since you're using 4 of them, you're going to need something to kind of manage the balance between the cells. Now, why do this? Lithium iron phosphate cells, even if they're bought together in the same pack, tend to age differently over time. And so, and especially if you're doing this with used cells, you will find that they're in different states of charge and different capacities. So something like a BMS will be helpful to keep the cells in balance as well as protect them from overcharging, over discharging, and shorts. Now this is called a Dali BMS, and what this is it's a nice unit here, fully sealed. They profess this to be waterproof and dustproof. That's why I really like these. But this isn't the only kind that you can get. This one is rated for 100 amps. But another popular one that I have is called the Zhaojiang BMS, and this one, it comes in fancier versions where you have even a little module in here, and you can run an application on your phone that connects to this via Bluetooth and tells you all the different cell voltages, the state of the charge, and all that. You see these little wires coming out here. These are actually temperature sensors that you can use to measure the temperature of the battery, and it will actually stop the battery from charging if the battery gets below freezing, because it's never good to, you could actually damage a lithium iron phosphate battery if you charge it at below freezing temperatures. So let me flip these over so you can see how they are on the side here. This BMS also has a temperature sensor, you can see. It also comes with this little cable system here, or lead system, and this is basically, it plugs into here, and it is your different BMS leads. And I'll be showing you later how to use this to connect up against your 4 cells. Other tools that you'll need for building your battery include a multimeter. I have here a clamp meter, but it has the measuring probes here. You'll need a pair of wire cutters, and they also serve as crimpers, which we will use. In this case, we have screw terminals with the Phillips head. So I have a little Phillips head screwdriver here. You also have these bus bars, which are essentially how you bridge the connections to make a series. So these are going to be used in a way to connect these batteries. And then of course you need your safety glasses. Always wear safety glasses when dealing with batteries. And in fact, I'm going to put them on right now. So we have here the 4 cells. What we're going to do is we're going to first measure the voltage of each of these cells. So I'm going to set this to measuring voltage, take my leads, and let's see here, 3.2122. Oh, 3.22. 3.22. Wow, they're all the same. And 3.223. So this pack is managed was shipped together, and they're all pretty much the same voltage, which is great. Oh, something else that I didn't do here is you'll notice this will show a negative or a positive depending on how I've done it. This is the positive probe, this is the negative. And if I put it this way, you see that it says 3.22, but if I do it in reverse, it says negative 3.21 now. So this tells me that this one is the positive terminal, and this is a negative terminal. And if I look closely here, you can't really see it in this video, but I see a little plus here. I see a little minus here. This is something important to note, because you look at the battery, you would think black means negative and the other color means positive. But in this case, black means positive and this is negative. So just bear that in mind. So what we're going to do is we're going to set these up to essentially be a series pack. So what we want to do is we want to connect. So this is going to be our positive. This is a negative. And so I want to be able to connect the battery so that I can connect the BMS here to the negative. So I'm going to say I want to do, in series, I want to do positive to negative, and then to positive to negative. So I'm going to have to flip these around. I hope you're keeping up here. But, oops. And you have to be careful when you're doing this, because if you do it wrong, you could actually close a connection and cause the batteries to short, which could lead to sparks, overheating, and you could even start a fire. So you need to be very careful with these things. Another thing that I failed to mention here is that these batteries came with a holder, and these are the holders right here. I kind of put them together already, but these go on top. This would cover this, and these go on the bottom. So what I'm going to do is I'm only going to use the bottom pieces to space them out properly, but I'm not going to use this top because it has all this stuff in the way, and I want to be able to give you a clear view of what's going on with the bus bars. So I'm going to put these in here. Here we go. Put these in this holder. Now we have this pack. What we want to do is we want to take we get 3 bus bars, and so we want to take the first one and do this, right? Second one here, third one here, and that will give us a positive terminal that's open and a negative terminal that's open. And so let me do that now. And when doing this, again, be very careful not to accidentally bridge the terminals so that you close a circuit. And what does that mean? Just never let the open circuits, whether they be these two after you're done, or if it's like this, don't close these two. Just never have it so that you close a circuit and start a short. So I'm going to put the first one here, right? Screw these back in. Also remember that when you're doing this, never torque these too hard, because these screws, these threads are not actually that strong, and I believe this is an aluminum terminal, so you don't really want to crank down on these. It will actually damage the threads, and then you're in trouble, because there's really nothing you can do to fix that. So we'll do this one. You see they're kind of flopping around. That's because I didn't use the top holder, but these bus bars will hold it in place for our purposes. There we go. And then the last bus bar. So now we have 4 cells that are connected in series. With this last one with thread for me. Here we go. There we go. So now, this is essentially, right now, this is a 12-volt battery. You have your positive terminal, your negative terminal. And then you have a series connection that makes sure that they're all connected together. Now, very important, never bridge these 2 terminals, never bridge these 2, never bridge these 2, right? In fact, sometimes I get something like an electrical tape or a Kapton tape, and I just cover these so that I'm not actually risking any short while I'm working on it. But if I were to take my trusty multimeter again, turn this thing on, and I measure here, tells me it is 12.88 volts. I don't know if you could see that with the reflection. So we have a good connection. So now we're going to put this battery aside and we're going to get the BMS ready. So I'll push it over here and get my BMS. So this is my BMS here. Essentially what we're going to be doing, and I'll show you here in a little diagram, is we're actually going to connect the BMS to the battery and the different leads to each of the series connections so that it knows the cell values of each battery. And that's the voltage values. So here's a little diagram that I have here. And you can see in this diagram that this is a DALI BMS. It's a common port BMS. And it actually has a battery minus at the bottom that connects to the pack battery minus, or battery negative. And then you're also going to take each of the leads. One of them is a black wire, and the subsequent ones are for the first in series, second in series, third in series, and then of course the positive. And then finally, you're going to connect your positive terminal to wherever your load is, and that's going to be paired up with the P minus, or the pack negative, which will then be your positive and negative terminals for your ham radio. So if we go, we'll see that this little bundle of wires here, and for a 4 series pack there should be 5 wires here. You see there's a black one and then 4 red ones. Then you see this is labeled B minus, which is battery negative, and this is P minus, which is pack negative, which is the output. Now each of these are open because they don't know how you're going to connect them, so they assume that you do that. In our case, we're actually going to be pulling in some ring terminals, and I didn't mention earlier, but these are definitely something you might want to get if you're building a battery pack. You can also theoretically strip these wires and then just wrap them around and torque them in, but it's a lot better to use ring terminals. And I know that these screws are M6 screws, and so what I'm going to look for in this little guide is the red ones that do 22 to 16 gauge wire. This is a very thin wire. My guess is that this is a 22 gauge wire. And so you're going to use the M6 screw for the 22 gauge wire. So I'm going to need 5 of these, and I'm going to crimp them up. So I'll put this away. And so you're going to take, like, let's take the first one, which is the black wire. And then you're going to strip that wire. Let me see here. So maybe I should do a little more than that. There we go. So there's my 22 gauge wire. I'm just going to put it into here. This is a very small wire, so sometimes you may even have to solder these, but I think I'm going to be able to do this. Just crimp it down like this. Let's see, did I get it? Oh, I didn't. Okay, so it looks like I'm not going to be able to crimp these because the ring terminals are a little too big for the battery lead, so I'm just going to have to do it the old-fashioned way with soldering. And so what I'm going to do is I'm just going to string this through here, get it just right, and then so I'm using my magic hands here, and then grab some solder. So I got my soldering coil here. I got my trusty TS100 electronics soldering iron. It's super small, runs on USB-C. And I'm just gonna put some solder in here. Just make sure that it gets in there. Oh, come on, get in there. That's the first of them. Let's see if it took. Yes, that was hot. Mistake of mine, but yep. So that's one terminal. So I got to do the rest of the 4 leads similarly, and I'm not going to make you sit through that. So I'll be right back when all the ring terminals are on there. So here we have the remainders all soldered in. We have each of the BMS lead wires with a ring terminal on them. And so now we're going to connect the BMS to the cell pack. Let me get this out of the way here. So we're going to bring in the pack, and as you can see again, it is connected in series. We have BMS ready to be connected to it. What's going to happen is this B- is going to be connected here. That is the negative terminal. And then this is very important. You need to be very careful when connecting these BMS leads. Preferably what they say is to remove this from its port and just have the leads. And then each one of these needs to be done in order. So this black wire needs to go to the pack negative. Then the one right after it, so you got to look here and get the next wire right next to the black wire. And that one is going to go to series 1. It can be either one of these terminals. Then you go to the next wire right next to it. This is the third wire. And that's going to go to series 2. Right? I tend to put them on the positive terminal of the series. Then you're going to get the next one after that, the 4th wire, and you're going to put that here or here, the 3rd series connection. Then finally you have the last wire, and that goes to pack positive. So you're going to have 2 connections, this connection and the black lead wire here to start off. So let's do that. So I'm going to remove this, and I'm going to string it through here. Well, actually, let me get the lead first. Get the BMS lead. I got to orient it the right way, and then get the black wire. I'll put these 2 together. So I'll put this here, and then string this through. Sorry, I'm in the way here. String these through like that, and then put it right here. And you'll notice that I did not cut the leads. Sometimes people like to cut them for the exact length that they need. And so what that means is what we're dealing with is just, exact distances to the BMS. But what I'm doing is I'm leaving them all long. I'll just kind of fold them up and neatly tuck them away. Also get this out of the way. So I'll let that hang there, but that's the initial connection. You just kind of get it hand tight there. Now I'm going to get the next wire. That's this one, right next to the black wire. And I'm going to connect that here. So if you get this wrong, you could actually end up messing up your BMS, shorting something inside. So it's very important to get the balance leads right. I have personally in the past done this incorrectly and then ended up frying my BMS, and that's a costly mistake. So now doing the third wire that's next to that one, and it's going to go here. There you go. Now we're going to get this again, this harness. This is the fourth wire that's next to the one we just connected. And we are going to connect it here. And finally, the last wire. That goes right here. And this is pack positive. Now those of you who are new to batteries, you know, you're working with a high potential current, but it's a 12-volt battery, so you can actually, you know, touch these and nothing's going to happen. But if you're dealing with higher voltages, such as, you know, like 48 volts, you can actually harm yourself. So it's best if you wear protective gloves and be careful not to short terminals if you're working with those higher voltages. So we have kind of a connection of wires here. We have the BMS connected to the B positive. I'm just going to plug this in the port in the back. Boom. And so now the BMS should be active. So if I get my trusty multimeter and I set that to voltage again. Let's see if I can get it so you can see it. Here, I'm going to prop it up against this so you can see the display. Oh, it still fell off. So here is, first we're going to measure the battery itself. So that's positive and negative, 12.88. So if everything is working correctly and it's going through here, it's being balanced and the leads are all connected properly and it's sensed all the voltages of the cells, then this right here should be the same. Let's see. There you go. 12.88, just like if I went directly to the battery terminal. So that means that the BMS is working. Let's do that again. 12.88. I could even turn on the light here so you can see it. 12.88. Excellent. So essentially what we have now is a battery. Everything is wired up and completed. Let me clean up a little bit around here. And so with this, what we can do is, naturally, we don't want this just hanging, right? So I have these little double-sided strips that I use, or 3M. 3M is also known for a tape, a double-sided tape they call VHB tape. But I'm just going to put a little bit of that on the back of this so I can stick it. Other people, what they like to do is they like to grab a roll of Kapton tape or a roll of electrical tape, and they'll just actually just tape the whole battery and tape this down. And then of course you have this spaghetti of wires, and so I'm going to clean that up a little bit and make it so that it actually is out of the way. But for now, just to stick the BMS on the battery so it doesn't just hang there and provide tension to that terminal, I'm going to just, oh, if I can get it right, it doesn't want to. And this double-sided tape is pretty good because it is heat resistant. Just put it on the back of this side. Let's see if we can see it. There you go. And I'll just stick this right here. Let me turn this a little bit so you can see what I'm doing. So I'll just stick it right there. So now I essentially have my battery and I have to connect, oops, just came off. Crank it down a little bit more. Now, it is probably better to also wrap it around just so that it doesn't do that. But I have my positive terminal and my negative terminal right here. And so now what are you going to do? You can get your wire, get a couple of power poles. Oops, this thing keeps falling off. I'll just leave it for now. You can get your power poles, get your power pole crimper, right? And you know, I tend to use a terminal screw right here, and I connect another piece of wire that has an M6 ring terminal on it, and then I have that go to match up with the positive wire, a red wire that comes out of here, and there you go. So what I've done here is I have actually connected a positive and negative wire, output wire, with power poles added to them to the battery. So you can see here I actually cleaned up the BMS leads as well, kind of tucked them behind here so that it looks a little neater. So one of the questions one might have after building this is, how do I charge this? I mean, all I have is this single output port. Well, there are a lot of solutions out there, but all you really need is a power source that is at 14.6 volts. This is one of the things that you can get out there. It's kind of a typical brick charger, and I don't know if you could see there, but it says LiFePo 4 charger, and this one in particular outputs, it seems a little bit, I don't know if you can read that, but it says 5.0 amps. So this charges at 5 amps. We're dealing here with a 100 amp hour battery, so that means it would be about 20 hours at least to fully charge this from zero. That's one option. It's a slow charge. It has a barrel connector, and so naturally you're going to have to get a barrel. It's typically a 5.5 millimeter by 2.1 millimeter barrel jack, and you have to get one of those jacks to convert it to power pole. So I have one of those right here. So I just made this. I just took a power pole set, connected it to one of these. These are marketed as like CCTV connectors, but they have the right jack. It's a 5.5 by 2.1, and so if I connect this here like this, now I can charge it. The nature of this BMS here is it is a common port BMS, so it only has one port that goes to the negative. So therefore, charging and discharging all come from the same port. If you want to use something like solar, you could do that by adding to the output port something like this. This is a splitter. You can find these on eBay or various ham stores. And this splitter basically creates 3 extra ports for the one connection you have. So if I connect this here, now I can connect things to here and here and here. And so you would get your solar panel with a charge controller to make sure it's the right voltage, and you would connect it to one of these, and that would charge the battery. Then you could use the other ports for output. Lastly, I want to mention, other than a standard wall charger, you can use a normal type of power source. So I have this here. This is a kind of like a variable power source. And this thing, it's supposed to go up to 30 amps. I have not used it at that high, but I have also connected to it a pair of alligator clips. And so I use this for individual battery charging, like individual cell charging if I want to top them up before putting them together. Or I use it to charge completed batteries as well. And so if I just turn this on, you can see that right now it's set to 3.6 volts, so I can change that. And remember, it needs to be at 14.6 volts. And right now it's at 3 amps. I mean, I could set it, to 5 amps. And then if I put that here, and then connect the plus and minus, might spark here. There's capacitors, I believe. Yeah, there was a tiny spark. And now if I hit the output button, there. Since this is fully charged, it's not really doing that much in terms of amps. But now it's going to charge it all the way up to 14.6, at which point the BMS should just cut it off once it's full. So I'll turn that off for now. So that's how you charge this battery that you've made. You can use any number of methods. There are solutions out there. All you have to really do is search for LiFePo 4 battery charger. And there are commercial options, there are smart chargers, or you can get one of these ones specifically for this type of battery. So I have a positive cable going here, and then I just took a little nut and bolt and got a crimp on a ring terminal and put it on there. And so now I have 12 volt power. And you notice here too, this is the temperature sensor probe. I just taped it on there. Also kind of tucked away the BMS leads behind this and used some Kapton tape to just kind of affix it here. I do want to mention that, you know, a lot of people, myself included, once I've gotten to this point, this is the battery. I don't actually even do much in terms of putting it in a case or trying to get it to be anything else than this bare battery. I understand though that a lot of people will be using these out in the field, and so sometimes you will want to build a case for it. I know people who put this kind of a battery in a Pelican case and cart it around that way. Others get more elaborate. They have woodworking skills and they build a custom box perfect to the dimensions of this battery, and they are able to make it so that it's a self-contained and well-protected battery. And so there you go. So what I wanted to demonstrate before we end here is I just really wanted to show you how the battery works with a radio. So I got my trusty pack here. This is my portable pack. It has my FTM 6000 by Yaesu, and in a cage, and it's in this nice little bag. Now inside here there is a smaller battery I made, much like this kind of battery that I'm working on, and that is normally what I have with this pack. That's why this is a self-contained pack. But for our demonstration purposes, I'm going to disconnect that pack. I'm going to take the leads here and plug in our new battery. And then power it on. Let me see if I can find where the power button is. Oh, there it is. And there you go. It's reporting 13 volts. And I have it set right now on my WinLink gateway frequency of 145.630. But there you go. Thank you for going on this journey with me. That is how to build your own lithium iron phosphate battery from cells and individual components. And all you really need is maybe some soldering, ring terminals, a wire cutter, crimper, power pole crimper, and a screwdriver. And everything else pretty much is pretty easy to put together. Hopefully this will lead you to some ideas on how to power your own station. Again, this is 100 amp hours, so that is significant. That's like 1.28. If you say that the nominal voltage of this is 12.8 volts, that's 12.8 times 100. So that's 1.28 kilowatts that you could carry in a very light package. I don't have a scale with me, but I would say that this is I don't know, my guess is less than 20 pounds. So something that's definitely pretty portable and will give you quite a bit of power for operation, especially with if it's just VHF like this rig right here. I would imagine it would last the whole day, you know, on a 50% duty cycle, but who knows? Depends on how much you actually are operating. So for something like field day or winter field day or something emergency communications, such a battery would be very, very helpful in the field. Again, my name is Dennis, Alpha Delta 6 Delta Mike, and thank you again for watching.